Have you ever heard of a puzzle so famous it created an entire new branch of mathematics? Let's travel back to the 18th century, to the Prussian city of Königsberg. The city was built around a river, with two large islands connected to each other and the mainland by 7 distinct bridges. The city's residents loved a good challenge, and they came up with a famous one. Could a person plan a walk through the city that crossed each of the 7 bridges exactly one time? It sounds simple, right? People tried for years, starting from different points, trying every combination they could think of. They would walk the city, trying to find this special path, but no one could ever solve it. Every attempt either left a bridge uncrossed, or required crossing at least one bridge twice. It was a frustrating and fascinating local mystery. Was it truly impossible, or had no one been clever enough to figure it out? The puzzle eventually caught the attention of the legendary Swiss mathematician, Leonhard Euler. Instead of trying to walk the paths himself, Euler approached it from a completely different angle. He realized that the exact shape of the land and the length of the bridges didn't matter at all. The only thing that was important was the relationship between the land masses and the bridges, the connections. This was the stroke of genius. Euler simplified the problem by representing each of the 4 land masses as a simple dot, which he called a vertex. He then drew lines, or edges, between these vertices to represent the bridges that connected them. By stripping away all the unnecessary detail, he created a simple diagram, a graph. He wasn't just solving a puzzle, he was inventing graph theory, a field of math that studies networks and connections. With this new graph, the solution became clear. Euler realized that to walk a path that enters a landmass and then leaves it, you need an even number of bridges connected to it. One to get in, one to get out. A path could only start or end on a landmass with an odd number of bridges. For a complete path to exist, there could be at most 2 odd vertices. But Königsberg's graph had 4 odd vertices. All 4 landmasses had an odd number of bridges. Therefore, Euler proved with mathematical certainty, the walk was impossible. So, while the residents of Königsberg never got their perfect walk, their puzzle gave the world something far more valuable. Graph theory is now a fundamental tool of the modern age. It powers the GPS in your phone, figuring out the best route from A to B. It's used to design the internet, analyze social networks, and solve logistical problems for everything from airline routes to package deliveries. It all started with a simple question about 7 small bridges.